Okay, here we are at what I think is going to be our last video from Chapter 9. And here we're going to look at some problems. These are problems taken from the back of the textbook, not from the application problems, but or from the study guide. But I feel like these are good examples of problems that you're also going to be working in the study guide. So we're going to look at all of these on this sheet from problem number 42 to problem number 46. So let's start with problem number 42. So let me read this for you. It says, use an adequate scale to show all the following. Make a sketch that shows the pattern locating tolerance zones for the given drawing. Show datums, true position requirements, and tolerance zones. Superimpose the feature relating tolerance zones. The feature relating tolerance zones must be shown with some amount of permissible offset from the true positions for the pattern locating tolerance zones. See figure 9-5. Now that's important, see figure 9-5, because that is really what we're going to be basing this on. All right. And so we have our drawing right here. We have a rectangular block. And we have 3 holes here. The 3 holes have a tolerance of 312 plus 7th thou minus 0. And then we have a composite positional tolerance where the upper segment is the pattern locating tolerance zone is an 030 tolerance zone at MMC relative to A, B, and C. Here's A, here's B, and here's C. And then the lower segment, or the feature locating tolerance zone framework, is an 010 diameter at MMC relative to A, so oriented relative to A. Okay, so let's see how we're going to do this. So what we're going to do is we're going to mark out, basically, we're going to locate these tolerance zones on a superimposed figure of the outline of the part. All right, so here we go right here. All right, so there we go. So here's the outline of the part, and you can see I have a very light sketching of the center of the holes, right, which we'll use for the pattern locating tolerance zones. So the first thing that we want to do is we want to locate the pattern locating tolerance zones. Okay, so the pattern locating tolerance zones are a diameter of 030 at MMC, and they're going to be fixed in position on these centers defined by the basic dimensions here. Okay, so I want to make sure I draw these big enough because I'm going to have to get something else in there too, as you'll see. So there we go. Okay. Now, the size of each one of these 3, these are 3 times a diameter of 030 at MMC. Okay. 030 at MMC, all 3 of those holes. Where are they located? Well, they're located 90 degrees relative to A. A is the bottom surface of this. From B, they're going to be, remember, this is B. I'll put this over here, right here. This is B. So from B, this is going to be 0.450. And $9.75, and from C, remember this is C, this is going to be 0.6, 1.2, and a further 1.2. All right, so these are the 3 tolerance zones and where the tolerance zones are fixed. Okay, according to the basic dimensions and the size on the tolerance zone on the feature control frame. All right, now, for the feature locating tolerance zone, the feature locating tolerance zone is a diameter of 0.010 at MMC. Okay, so that's a smaller hole. Okay, and I'm going to use this scale to kind of help me get things oriented. So let's say that we go right there. You'll see what I'm doing in a second. I'm basically trying to locate and show them with enough offset. I think that one would go there. Okay. So now this dimension from here to here, actually that should be a little bit more like at a flat angle. This is going to be 975. Okay. This dimension from here to here is going to be 2.4. Right? 1.2 and 1.2. Or this 1.2 from there. Okay. So notice what I've done here. Notice that the feature locating tolerance zones are within the pattern locating tolerance zones. Now that is not strictly necessary. Okay, so let me show you here. Really, what we're concerned with is the center of the hole. So if I have a tolerance zone for my patterns there, I can have a center that is right here. That would make it so that the feature locating tolerance zone actually is outside of that. But as long as the center doesn't leave, the center of the hole cannot leave both of the green and the red in this case. Okay, so just to make things a little bit more understandable, I've made sure that my feature locating tolerance zone is always within my pattern locating tolerance zone. That way, I never have a situation where the center of my hole is outside of the boundaries of both. But in point of fact, I could have my feature locating tolerance zone in such a position out here so that most of my feature relating tolerance zone is outside of this, provided that the hole, the center of the hole, the axis of the hole, is not outside of the green. Okay. So I didn't want to confuse you. You know, that explanation might have confused you, but I didn't want to confuse you with the drawing. Okay. So this is the answer to problem number 42. So what we're doing is we're just showing possible configuration of the feature relating tolerance zone framework, the small red tolerance zones. Note though that the pattern locating tolerance zone is kind of fixed in space. There's no variation for how it's positioned because we have to obey these dimensional constraints, these basic dimensions, locating it from A, B, and C, and to each other. Okay. Now let's move on to problem number 43. So problem number 43 is going to be related to that. It says sketch a functional gauge for pattern locating tolerance zones in problem number 44. Include dimensions. Okay. And problem number 44 says sketch a functional gauge that checks hole locations for the feature relating tolerance zones. So basically we're creating two functional gauges. One for the upper segment, the pattern locating tolerance zone, and one for the lower segment, the feature locating tolerance zone. Okay, so two functional gauges. So let's look at the first functional gauge. Okay, so the first functional gauge, and I have here an outline. It's a little bit light, but I'm going to show the functional gauge. So the functional gauge, we want to show the datum simulator. So we have A is the bottom surface, which I can show right here. All right, this is A. And then B is the long side. So my functional gauge is going to have a wall right there. And C is my short side right over here. My functional gauge is going to be like that. Now, let me just wall this off because this would be a wall. Right? You can think of it like that. So I'll hatch that in like so that you can more clearly see that that's different. And then same thing over here. This is going to be a surface. So there's my functional gauge. So I would place the part in there. Now for the pattern locating tolerance zones, okay, I'm going to have 3 pins, and the 3 pins, let's get the calculation for the size of the pins. So the pins for the virtual condition for the pattern locating tolerance zones are going to be the size of the hole at MMC, which is 312, minus the tolerance at MMC, which is 030, equals 0.282. Okay, again, just to show you where I got that from, 312 minus 0 is the MMC of the hole, and then 030 is the tolerance. All right, so that's the normal virtual condition equation. So I get a virtual condition size of the pin of 282. And so that's what I'm going to have 3 pins that are going to be of a size of 282 right here. Three times diameter 282. Okay, right like that. These pins are going to be perpendicular to A. Okay, so here, let me just reiterate. This is a diameter of 282. And they're going to be located relative to B and C. So the distance from here to here is going to be 450. The distance from here to here is going to be 0.975. The distance from, I'll pull this out a little bit, from here to here, 0.6, and from here to here is 1.2, and from here to here is 1.2. Okay, so we're going to have 3 pins in our functional gauge, like so, and the pins are going to be a diameter 282 in size, and we're going to put the part down on top of that. All right, so that's functional gauge number 1. That's problem number 43. Now, let's work on problem number 44. And in problem number 44, we're going to sketch the functional gauge for the feature relating tolerance zones. So the 010 at MMC relative to or oriented to datum A. All right, so the gauge is going to be similar, but it's going to be different in some important ways. So here I have another sketch just outlining the rough shape of the block to give us kind of an idea of where the pins are going to be. Let's first calculate the virtual condition. The virtual condition for the feature locating tolerance zones is going to be, and here I'll pull this in here so that we can see, 312 minus 0 is the minimum hole size, so 0.312 minus, and the tolerance zone, the feature locating tolerance zone is 010 at MMC, so 010 equals 0.302. So that's the virtual condition size, or the pin size for the feature relating tolerance zone framework. Okay, so then what we're going to do is we're going to have 3 pins now at this location, and this location, and this location, and these 3 pins are going to be 0.302 in diameter. All right, and the pins, their only orientation requirement is that the 3 pins are perpendicular to A, right? So there's A, right? And the pins are located relative to each other. Whoops, this is 2.400. And this is 0.9750, right? 2.4. Okay. So notice that we don't have anything for B and C, right? No datum orientation requirements for B and C, right? So only A. The pins must be perpendicular to A, and the pins are located relative to each other. So as long as we can get our part on those 3 pins, and we don't have to worry about bumping it up against B or bumping it down, well, this is C, and bumping it up against B. As long as we just have the requirements of placing it down on A, then we're good to go. Okay, so that is problem 42, 43, and 44. This is 44. This is 43. And then 42, remember, was this with where we're representing the tolerance zones. Now, I kind of exaggerated these tolerance zones just so you could see clearly, right? But remember, the tolerance zones are given here, and the tolerance zone, actually, I left this out. The tolerance zone for this 3 times is 0.010 at MMC. Okay. All right. So now let's look at this one right here, problem number 45. Sketch a functional gauge to check the position tolerance, all right? So position tolerance shown in the given drawing. So this is not a position tolerance. That is perpendicularity. So here's the position tolerance right there. Include dimensions, but assume that the gauge needs no tolerance. Okay, so here, the positional tolerance we're talking about these 2 holes, the positional tolerance for the 2 holes, and here's really the kicker here. The positional tolerance is 0.15 inches at MMC relative to A primary and B at MMB secondary. B at MMB. Well, what's B at MMB mean? Well, look, B is the hole here. What is the maximum material boundary of B? Well, the MMB of B is going to be equal to 1.015, right? The MMC size of the hole minus 0.004 equals 1.011. So what is the tolerance? What is the gauge? We're looking for a functional gauge. What is the functional gauge going to look like? Well, here's what the functional gauge is going to look like. So here I have, this is the part, right? And the only reason I've drawn the part is so you can kind of get a reference here. But we're drawing the functional gauge. So I will draw this in red so that you can see that. So first of all, the pins, what size do the pins have to be? These pins right here have to be equal to 0.281 minus 0.015 equals 0.281 minus 0.015 is 0.266. 266. Right? So I'm going to have a pin here and a pin here. And the pins are going to have, there's going to be 2 times diameter 0.266. That's not the neatest 6 right there. Okay, so there's my 2 pins. The pins are going to be right there. Okay, and right here. They're going to be perpendicular to A, right? Here's A. That's the bottom surface here. And their location relative to each other is a diameter of 166. So this dimension right here is 1.688. All right, but we also need, because it's A, B, M. So that's the A part done. Now we need to look at that. All right. So B is this hole. So in order to simulate B, we have to make a pin, right? A pin that's going to sit right in there. Sorry for my non-round circles there. And I'll continue to do it here. And the pin is going to have a diameter of the MMB size of the hole, which is equal to 1.015 minus 0.004 equals 1.011. So the size of that pin right there is 1.011. Okay. So that's the functional gauge. Now, if I take out the rest of the stuff, if I take out the drawing of the part, let's just look at what the functional gauge looks like just from that. Okay. And I'll reuse a sheet of paper here. All right. So the functional gauge then would look like this. It would be a plate here with a large pin there, and a small pin there, and a small pin there. Okay. These pins would all be perpendicular to A. This is datum simulator A. And then this is where it's going to get a little bit messy, possibly. I'll try to draw my circle as good as I can. Two times diameter 0.266, diameter 1.011. All right, so there is my functional gauge. All right, so you can think of it as it's going to be basically 3 pins, a large pin in the middle with 2 smaller pins on the outside, and our job then to check to see if the part is a good part or not. We're going to take the part that we get out of the machine, when we're done with it on the machine, when we're done milling it or whatever it is, we take the part out and we have to push it down on this. We have to get it to sit on this gauge. And if it sits on this gauge, then it's a good pin. Now, let's just think about this for a second. So the part that we make, the center hole has a diameter of 1.016 plus 3 minus 1/1000. Okay? And it's going to go down on this 1.011 pin. Well, that should work, right? If the hole size doesn't get less than 1.015, right? 1.016 minus 1 is 1.015, then it should be able to fit on a pin that's a size of 1.011. Bear in mind that we also have 4 thou at MMC of perpendicularity that we can play around with. All right. So in order to check now these two holes on the side, we're going to have this pin 1.011 and these 2 pins of 266. These 2 holes are 282 minus 1/1000, so 281. Again, you would think that a 281 hole, smallest hole that we can manufacture, a 281 hole, could and should be able to sit down to go around 266 holes. All right? And I forgot to put this in here. Let's make sure the distance between this is 1.688, and it's halfway between this, so 0.844. So this is 0.844. Okay. So that's what you have to remember. With a functional gauge, these pins are designed, they must be smaller than the holes that they're going around. But the size of the pins, the size of these pins, takes into account the positional tolerance. And in this case, also the perpendicularity tolerance, because we're looking at the maximum material boundary for that and the virtual condition size of those. Okay. So that's problem number 45 then. All right. And the last problem we're going to look at is problem number 46. And number 46 says, sketch the necessary functional gauges to check the feature relating tolerance zones in the given drawing. Include dimensions, but assume that a gauge needs no tolerance. Okay, so here we have, again, another rectangular block. Here we have 8 holes. We have 4 holes in this pattern with a diameter 156 plus 6 thou minus 0. We have a composite positional tolerance here of 032 at MMC relative to A, B, and C for the pattern locating tolerance zone framework, and a diameter of 0.012 at MMC for the feature relating tolerance zone framework. And then we have 4 holes in a line here, diameter 125 plus 5 thou minus 0, with a pattern locating tolerance zone framework of 032 at M relative to A, B, and C, and 6 thou at M relative to A. So, just to reiterate, we have one datum reference that's the same for the pattern locating tolerance zone. So that's going to be one gauge. So the number 1 gauge is going to be both pattern locating tolerance zone frameworks together. Okay. The second gauge is going to be the diameter 156 feature relating tolerance zone framework, and the number 3 gauge, the third gauge, is going to be the diameter 125. Okay? So we would need a total of 3 gauges to check this part, to check the positions of these 8 holes in this part. All right. Now, the question only asks us to do the feature relating tolerance zone. So that's the only one that I'm going to do. So here we have, I have a light outline for the 2 parts, and we'll use this, and I'll use red again just so it stands out a little bit better. So for this would be gauge number 2. Right? So for gauge number 2, we have a virtual condition of 0.156 minus 0.012 equals 0.144. All right, so we're going to have 4 pins right here. Four times diameter 0.144, and these are going to be 0.406, 0.750, and that's it. Okay. No other dimensions, right? So we don't locate these relative to these other 4 holes. We don't locate these relative to the datum references. The only thing that really we need to locate them to, or orient them to, is they have to be perpendicular to A. So, perpendicular to A. All right, so there we go. Now for gauge number 3, the virtual condition for gauge number 3 is going to be 0.125 minus 0.006 equals 0.119. So these 4 holes make sure I can see, you can see that 4 times diameter, 0.119. And these are going to all be in a line, right? They're all in a line. And they are 0.75 apart like that. So there is your 2 functional gauges. Okay. So you're going to have 4 holes around here on a plate. You're going to have 4 holes in this square pattern on a plate. The pins, excuse me, I shouldn't say holes. 4 pins, right? And the pins are going to be perpendicular to the plate. 4 pins here, the pins are going to be perpendicular to the plate. The size of the pin is given by the virtual condition calculation. All right. And that's problem number 46. Okay, so hopefully that will help you complete the application problems. If you have any questions, please email me. Let me know what your thoughts are and what you're having problems with. I'll be more than happy to meet with you. We can set up a web meeting if we need to do that. So get started on this because there's a lot of drawing in this assignment, sketching in your case. So that might take a while. And, when I was setting up for this video, I went through a lot of pages, sketching pages too. You might do the same. So, just take that into account with your time management. Don't think that you're just going to be able to go through from start to finish without making any rough copies or without messing up and needing to restart. Okay. With that is the end of chapter 9. Like I said, please let me know if you have any questions, and I'll help you as much as I can. All right. Thank you. Bye.